Hi there. Today's video is really going to piggyback off the last one. Today we're just going to have to set up a triangle ourselves instead of being given, oh by the way, side B is 4 units long. Here we're going to be given like a word problem and we're going to have to set up that diagram ourselves. But really other than that, the problems aren't all that much different. So let's jump right into an example. A person is standing 90 feet from the base of a building. I'm just going to draw that much for now. Here's my building. Here's the person. This is 90 feet. The angle of elevation from the ground to the top of the building. Now they're going to talk a lot about angles of elevation and angles of depression probably in these problems. Keep in mind, an angle of elevation or an angle of depression are both measured against a horizontal surface. So what that's saying is the ground is the horizontal surface. The angle that the person's eyes make with the ground is 50 degrees. If they were talking about angle of declination or angle of depression, that would be a person standing at, say, the top of the building looking down, but they would still be dealing with a 50-degree angle against the horizontal surface. The angles of depression get weird for people because they're outside the triangle, but if you consider that the ground and the sky, or the ground and the horizontal portion of the sky are parallel, that makes this a transversal, and it makes these alternate interior angles, so they'd be congruent anyway. And they're asking for the height of the building. I'll call that x. Well, from here it's just going to be a problem a lot like the last video. We are given an angle, we are given a side. By the way, this is a right angle. Assuming this is not a tower in Pisa, Italy, we can assume that this is vertical and this is horizontal. Therefore, this would be a right angle. So again, we are given an angle. We know its adjacent side. We need its opposite side. And because of that, if adjacent and opposite are involved, we're dealing with tangent, because tangent is opposite over adjacent. It's the tangent of a 50-degree angle. That's the angle we're working with. The opposite side is unknown. The adjacent side is 90. If you multiply both sides by 90, you will isolate the x. So 90 times tangent of 50 degrees is x. If you type this into a calculator, 90 times tangent of 50, making sure your calculator is in degree mode, you should get about 107.3 feet if you round off to the nearest tenth. I'll even label it this time. 1 tick mark means feet, 2 tick mark means inches. That was fun. Let's do another one. Here we have a baseball player. Hits a home run. That means the ball went out of the park. The bat made contact with the ball at a point 5 feet directly above home plate. So the ball was already in the air when it was launched. The ball traveled in a linear path. Okay, it's weird that a baseball would go in a straight line for a home run, but we're going to keep it simple and say it did. Hitting a sign on the wall 324 horizontal feet away. So here's the wall, here's home plate, this is 324 feet. The ball was also up 5 feet when it got its head start, and it went in a linear path, something like that. It hit a sign 48 feet above the ground, so this side is 48 feet. Anyway, they want to know how long was the linear path of the ball. So we're looking for this sloped distance. What I'm going to have to do then is realize this is not actually 48 feet anymore. It was 48 feet when it hit, but it got a 5-foot head start. So the actual triangle portion of this trapezoid is still 324 feet along the bottom. There's still a right angle there because the ground is flat and the wall is assuming vertical. We still need to find the side. And this is no longer 48 feet. This is 48 feet minus that 5-foot head start that it got because the ball was already off the ground when it was hit. So that really makes this 43 feet. So be aware of any head starts, anything you have to subtract off, or maybe add on in these problems as well. But from here, now with the triangle setup, it's a pretty easy problem. How long was the linear path of the ball? Oh, heck, I don't even need trig for that. I'm just going to bust out Pythagorean Theorem. 43 squared plus 324 squared equals hypotenuse squared. Again, a good calculator problem. 43 squared plus 324 squared gives you a pretty large number, 106,825. If you take the square root of that, you get about 326.8 feet. So it traveled a little more, because it was going up, it traveled a little more than it would have if it was just horizontal, which would have been 324 feet. But then it asks you for the angle of depression that the path of the ball made. That's measured off of here. Frankly, the angle of depression up here is going to be the same as the angle of elevation down here. So I'm just going to look at this as an angle of elevation problem where I'm trying to figure out the measure of that angle. Now again, if you're looking for an angle measure, you're going to need to use two sides that you know. It's okay to have an unknown side if you know the angle. But if you're looking for the angle, you darn well better have two sides that you know for sure. So the two sides I know for sure relative to this angle, which I'll call, I don't know, A for angle, is I know the opposite and I know the adjacent. If I know the opposite and I know the adjacent, then I can write an equation using tangent, because tangent uses opposite and adjacent. Specifically, I can say the tangent of my angle here is the opposite 43 over the adjacent 324. To figure out what A is in this case, I need to get rid of the tangent function, and nothing gets rid of a tangent function better than inverse tangent. So I'm going to apply inverse tangent to the left side, which will simply give me A by itself, and I'm going to apply inverse tangent to the right side, which means I'll want my calculator. I'm going to hit the second button, the tangent button, and then in parentheses type in 43 divided by 324. You should get about 7.6 degrees. So again, it was a pretty horizontal path. This obviously is not drawn to scale. Trust the numbers, not my awful, awful, awful diagrams. Okay, one more. This isn't really so much a word problem as much as just I want you to be used to understanding what the phrase solve the triangle means. And there in parentheses it tells you, it says find all three angle measures and all three side lengths. We're going to be doing a lot of problems in the upcoming lessons on solving triangles, so here's a little practice. I'm going to label, notice they don't have the sides labeled. I'm just going to label the sides. This would be small a because it's across from angle A. This would be small b because it's across from angle B. This would be small c because it's across from angle C. And I'm just going to draw a quick little box. If I can put correct numbers on all these blanks, then I have solved the triangle. And heck, a lot of these are given to you. A is 90 degrees. It says so in the problem. Angle A is. Side C is 7.3 units. It says so in the problem. And side A is 16.2 units. It says so in the problem. If I want to find side B, keeping in mind this is a right triangle, and I know two of the three sides, I'm going to use Pythagorean Theorem on it. I'm going to say one leg, 7.3 squared, plus the other leg, that's the one I don't know, that's b squared, has to equal the hypotenuse squared. Now, I know they call the hypotenuse A, and the Pythagorean Theorem it's supposed to be C. Adapt. You have to be able to adapt. Pythagorean Theorem basically says leg squared plus leg squared equals hypotenuse squared. It doesn't matter what you're calling A, B, and C. It can change problem to problem. What doesn't change is the logic. Short side squared equals long side squared. Let's do this. B squared is 16.2 squared minus 7.3 squared. So you should get this. By the way, this is 209.15. Take the square root of that to isolate the b. And if you round it off, you get about 14.5. Obviously, I'll just keep the positive answer only. We still need to find some angle measures. It doesn't really matter if you do B or C first. I'm just going to kind of pick one. I'm going to work off angle B here. And I know the adjacent side of angle B, and I know the hypotenuse of the triangle. And if I know adjacent and I know hypotenuse, I know cosine. Cosine is adjacent over hypotenuse. So the equation that I can write is cosine of my angle B is adjacent 7.3 over hypotenuse 16.2. To isolate the B in this equation, I need to apply the inverse cosine to both sides. Running out of room here. So it's a good calculator problem again. You should get about 63.2 degrees. Now if you want, you can write another trig equation to find angle C, but that'd be a little silly, because if you know two of the three angles, and you should know, of course, that the three angles should make 180 total, angle C is just going to be 180 minus the two things that you already have. So if you do 180 minus 90 minus 63.2, the only thing left for that last angle is a 26.8 degree measure. And you can kind of double check your work. Again, shortest side should be across from the smallest angle. Middle of the middle length side should be across from the middle measured angle. And the longest side should be across from the greatest angle measure, which all these are. Have fun out there.